Okay, good afternoon, students. Welcome back to our webinar price classes. This is a different topic now. Today we will discuss. In the previous classes, I have discussed with you the circles and the system of circles. Now we are going to discuss of the ellipse. That is the conic section. So first we have to know the what is the conic section definition. So first conic section definition, that is nothing but the locus of a point which moves in a plane such that the ratio of its distance from a fixed point to its perpendicular distance from a fixed straight line is always a constant, is called the conic section. So that is the basic definition for the conic. So conic definition, another a conic section is a curve obtained from the intersection of a double napped right circular cone and a plane. So what is saying here? So here a double napped cone is like this. So I'm taking a plane. So I'm taking like this, that plane. So this double napped cone cutting with or intersecting with plane. So that is nothing but I'm intersecting like this. So then I will get somewhere. That is if it is like this. So if you cut the cone, then you will get the some type of different types of figures as per the angles. So that is the definition. A conic section is a curve obtained from the intersection of a double napped right circular cone and a plane. Okay. Next, if suppose the cutting plane makes an angle beta, the cutting plane. So I'm taking with the plane with the beta, angle beta, with the axis of the cone, and suppose the generating angle of the cone is alpha. Generating angle is the cone is alpha. Then the section is, so sections are divided. So then what are the sections? See, observe this. So these two are generators. So the dotted line is the axis. Okay. So which is having some angle, that is generating angle. So that is generating angle alpha. So just to draw a double napped cone like this. So this is axis, this is the vertex. The section is here. I'm cutting a plane, only single cone. So here, what is I'm taking? Alpha equal to b. This angle, alpha equal to beta. So this angle is, these two angles are equal. So alpha equal to beta, that can be formed parabola. So next, so I'm cutting with beta values. What I'm taking here, beta value. So the beta value is pi by 2. Which means, so perpendicular to axis. This is the perpendicular line for axis. Then I will get a circle. Next, so this is 90 degrees for that one. So I'm cutting with a plane. So then the angle is alpha is less than beta is less than pi by 2. It forms a ellipse. An ellipse if alpha is less than beta is less than pi by 2. Next, so that is the alpha is less than beta is less than pi by 2. So next, one thing is there, a hyperbola if 0 is less than or equal to beta is less than alpha. If you take like this, so I didn't draw here. So if you get like, so hyperbola. So I will discuss later with you later. So then, so this is the conic section definitions. How will it generate the cones? So parabola, ellipse, circle, hyperbola. Okay. So this is next. So from the conic section definition, we got SP by PM equal to E. If E equal to 1, then the conic section is called as the parabola. And if E 0 is less than 1, then the conic section is called ellipse. If E is greater than 1, then the conic section is a hyperbola. So if the values of E values equal to 1, that will be said as called as a parabola. If 0 less than E is less than 1, that is called as ellipse. E is greater than 1, that is a hyperbola. Okay. Next. So now we are going to enter into ellipse chapter. So this is ellipse. So I'm drawing an ellipse here, same in the previous figure. So but here only discussing with only the ellipse. This is, so this is angle. Here what is saying that these lines are generators. This is vertex, this is vertex angle. Okay, these directrix, these are directrix, this is the axis. Okay, this is ellipse. So alpha is less than alpha value and beta value. With respect to the alpha value, beta value, will get the ellipse. So this is the figure of an ellipse. So next, a conic section is said to be an ellipse if its eccentricity is less than 1. So here E says that eccentricity is less than 1. 0 is less than, E is less than 1. So then that is called as an ellipse. Okay. Next, a second degree non-homogeneous equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents an ellipse. If h square minus ab is less than 0, h square minus ab is less than 0, and delta is not equal to 0. So what is the delta, sir? So abc plus 2fgh minus af square minus bg square minus ch square. So this is an ellipse. If this condition is satisfied, that will be said as called as a ellipse. Okay. Next, standard form of the ellipse is nothing but x square by a square plus y square by b square equal to 1, where a is greater than b, So this is the standard form of the ellipse. Now, so this is ellipse diagram. Please observe this. Okay, sorry, right. Here, see the center, and S is the focus. Two S is there, two focus is there, and this is the vertices A dash and the Z dash are the perpendicular to the x-axis are the major axis. Here, if A is greater than B, so these are the directrix. Z, this are L equal to 0, this line, and this line is L dash equal to 0. So these are directrix. So this is a ellipse diagram. Next, so I'm taking this and some definitions is there. So just I'm reminding you what you have in IPE. So this is an ellipse diagram. So I'm taking. So what is saying that focal chord? A chord is passing through the one of the foci of the ellipse. So one of the foci of the ellipse is, I'm taking here. You can take here also. This is passing through here. So then that is called as a focal chord. Okay. Next, that is LH. Double and a focal chord is passing through the point P. So I'm taking any point P lies on the ellipse. Then, and which is perpendicular to the major axis, of the ellipse is called the double ordinate of the P, double ordinate of point P. So this is the figure. So I'm taking, this is the perpendicular line. I'm taking here perpendicular line. So this is the double ordinate and the focal chord are discussed here. Next. So lattice rectum, a focal chord of an ellipse perpendicular to the major axis of the ellipse is called the lattice rectum. A focal chord is a perpendicular. So in the previous diagram, we see the one. So this, which will be the 90 degrees with the major axis, that is called as a lattice rectum. So focal distance. So this is important. The distance between of a point P on the ellipse x square by a square plus y square by b square equal to 1 from its focus S is called the focal distance. Distance between the S and P. Next, if let P be any point on the ellipse and S dash are the foci, then SP plus S dash P equal to A. So where A is greater than B, where SP and S dash P are called the focal distances. Only focal distances. Next. So from the focal distance, we got some formulas from this one. So this is ellipse diagram. So this is SP. Right. So observe this diagram, then you'll got an idea about this one. So SP plus S dash P equal to 2A. SP plus S dash P equal to 2A. So we discussed this one. Next. So if P x1 comma y1 is a point on the ellipse x square by a square plus y square by b square equal to 1, where a is greater than b, then the focal distances are SP value. What is the SP value? So here a minus mod of a SP value is mod of a minus ex1. S dash p equal to mod of a plus ex1. A plus ex1. So this is the if p of p x1 comma y1 is a point on the ellipse x square by a square plus y square by b square equal to 1, where a is greater than b, then the focal distances are SP value is there, S dash p value is there. That is a mod of SP value is mod of a minus ex1. S dash p equal to mod of a plus ex1. Okay, next, the focal distance of the ellipse if a is less than b. A is less than b. Here, see, x square by a square plus y square by b square equal to 1. The condition is a is less than b. In the previous one, a is greater than b. So now this is nothing but mod of b plus or minus ey1. Mod of b plus or minus ey1. That can be written as mod of b plus ey1, comma mod b minus ey1. Okay, next. If PSP dash is the focal chord of the ellipse, and SL be the semi-latus rectum, then 1 by SP plus 1 by S dash P equal to 2 by SL. 2 by SL. So this is proof. We have that one. And that is nothing but the semi-latus rectum is the harmonic mean of the segments of the focal chord. That is nothing but the semi-latus rectum is the harmonic mean of the segments of the focal chord. So major axis, minor axis. So in the previous discussion we got what is the major axis, so what is the minor axis. So just I'm reminding you that, so what are the major axis, what are the minor axis here. So a dash is the major axis and the b dash is the minor axis, and the length of the major axis is nothing but 2a, where a is greater than b, and the minor axis is nothing but 2b. So this is I'm saying that if a is greater than b, a dash is called the major axis, b dash is called the minor axis, and vice versa of a is less than b. If a is less than b, a dash is the minor axis and b dash is the major axis. So then the line segment a dash, b dash of the length is 2a and 2b respectively. Okay, 2a and 2b respectively are called the axis of the ellipse. So this is major axis and the minor axis. So notations, so this is one. So if equation of the ellipse in the standard form is s equal to 0, then s equal to, I'm taking this is x square by a square plus y square by b square minus 1. Then so s1 is nothing but x1 by a square plus y1 by b square minus 1 at x1 comma y1 at point x1 comma y1. Next, s12 equal to x1 x2 by a square plus y1 by 2 by b square minus 1 at x1 comma y1 and x2 comma y2. These are the notations. So s11 is nothing but x1 square by a square plus y1 square by b square minus 1 at p x1 comma y1. So this is the notations. So various forms, I'm reminding you that just various forms these are. So just observe this one. I'm not going to explain this, just observe this. So major axis, minor axis. So major axis along x-axis, minor axis along y-axis, length of the major axis 2a. So 2b at the minor axis length. So then center is 0 comma 0 and the foci is a comma 0, s dash s value is a comma 0, s dash is minus a comma 0, and so observe that one. So the equation of the directrix is nothing but x equal plus or minus a by e. So next eccentricity is nothing but e equal to root of a square minus b square by a square. So then one thing is here, end points of lattice rectum, that is nothing but plus or minus a comma plus or minus b square by a. For this, then so what is the condition here? So this is the condition. If a is greater than b is greater than 0, if a is greater than b is greater than 0, then we'll get this formulas. So then next, so if x square by a square plus y square by b square equal to 1, then the conditions like this. So see this one. So major axis, minor axis, just to change it. So this is so major axis y axis, minor axis x axis. So this is the length of the major axis bb dash, that is 2b. This is 2a, length of the minor axis here. So center is 0, 0, and the foci is S 0, plus or minus B, and so for equation of the directrix equal to x equal to plus or minus B by E, and eccentricity is E equal to under root of B square minus A square by B square. So end points of a lattice recta is plus or minus A square by B comma plus or minus BE. Okay. Next, so center, if it is in the previous two discussions, center at the origin, now center not at the origin, then we'll get this slide like this. So x minus h whole square by a square plus y minus k whole square by b square equal to 1, where 0 is less than a is less than b, then so center transform to 0, 0, 0 to h comma k. Then these are the directrix. So a dash b dash, so same as major axis minor axis. So major axis along y equal to k, minor axis along x equal to h. Then length of the major axis has 2a, minor axis is 2b, and center is h comma k is here. So now foci is nothing but s equal to h plus or minus a comma k, and the equation of directrix is x equal to h plus or minus a by e, and eccentricity is e equal to under root of a square minus b square by a square, and the end points of lattice rectums are h plus or minus a comma k plus or minus b square by a, h plus or minus a comma k plus or minus b square by a. So then next, see this x minus h whole square by a square plus y minus k whole square by b square equal to 1. So then, so observe the figure and formulas. So major axis is x equal to h along x equal to h, and the minor axis along y equal to k. Length of the major axis is 2b, and the length of the minor axis is 2a. Then center is h comma k is here. Now foci, that is h comma k plus or minus b, and the equation of the directrix is y equal to k plus or minus b by e, and the eccentricity is nothing but under root of e equal to under root of b square minus a square by b square. So and the end points of a lattice recta is nothing but h plus or minus a square by b comma k plus or minus be. So these are the various forms of the ellipse. So just I'm reminding you that one only. So next, so this we have that one L R a comma b square by a, and L dash is a comma minus b square by a. Then we have to find the length of the lattice rectum. That is nothing but length of the lattice rectum. L dash is equal, just you have to find that distance between the 2 points. That is x1 minus x2 whole square plus y1 minus y2 whole square, which is under root. Just you have to do that. Then you will get this value 2b square by a, 2b square by a minus a whole square. That is will be 0, and this is minus 2b square by a whole square. Square root cancel. Then you will get this value. So minus will be plus here. So that 2b square by a. This is the length of the lattice rectum. That is L dash equal to 2b square by a. So next problems. So if a dash are the vertices, a dash are the vertices of vertices, and s dash are the foci, and z dash are the feet of the directrix of an ellipse x square by a square plus y square by b square equal to 1, where a is greater than b with the center c, then cs, ca, cz are in. So just ap, gp, hp, agp. So he's asking that a dash are the vertices, okay, s dash are the foci, and z dash are the feet of the directrix on an ellipse equation with the center c. So then cs, ca, cz are, what is saying here? So I'm taking like this ellipse. So sorry, so just like this. So here endpoints a dash, this is I'm taking, this is a. So and one values will be like this. So this is z dash z, and this is center c, this is s I'm taking. So this is s dash. So what is asking? cs, cs, ca, ca, and cz, cz are in, and the options are AP, GP, HP, AGP. So just we have to find that one. Next, so solution for that one. So then solution of this one is the ellipse equal to, given that x square by a square plus y square by b square equal to 1, a is greater than b, then cs equal to ae. So this is cs, that is nothing but a focus. Focus is nothing but, we know that s equal to a comma 0. If the x square by a square plus y square by b square equal to 1. So then ca is nothing but the half of the major axis. Then cz, this is the equation of the directrix. So this is directrix equation. Then just we have to find the relation between the this CS, C and CZ. So then CA square equal to, I'm doing this, CA square equal to CS into CZ. So this is multiplying. So this is A square equal to, so A square equal to AE into A by E. A by E. Then this will be gets cancelled. A square equal to A square. So if I'm taking the CS is A, this is B, this is C. So then I got that values B square equal to AC. So then we have that one, that is nothing but geometric progression. Geometric progression. Okay. Next question. So option 2 is the correct one for this one question. So next. So the length of the lattice rectum. So length of the lattice rectum of the ellipse. So he given that 9x square plus 25y square minus 18x minus 100y minus 116 equal to 0 is. So we have to find the length of the lattice rectum. What is the length of the lattice rectum? We discussed in the previous. So there is nothing but 2b square by a. Just we have to find the 2b square by a. So but in the question he wasn't given that a b values is there. So we have to transform this equation to the standard form of an ellipse. That is nothing but, this is nothing but center h comma k form. So that is x minus h whole square by a square plus y minus k whole square by b square equal to 1. Then we have to solve. Then we'll get the a value and b value. Just substitute in the 2b square by a. Then you will get the answer. So for this, so options is 15 by 8 and 18 by 5 and the 5 by 18, 8 by 15. So these are the options. So first we have to do, so this is, so from these two, take so completing square method, then you will get 9 of x square minus 2x plus 1 minus 1. So then 25 of y square minus 4y plus 2 plus 4 minus 4. So just we have to solve that. So then like this, solution of this one, this is, I'm doing this. 9x square is 9x square plus 25y square minus 18x. So from these two, I'm taking the 9 common, then I will get 9 of x square minus 2x, so plus 1 and plus 25 of this value is y square minus 4y plus 4. So I'm taking this value into right side. Then that value is nothing but 116. That is a negative value. So taking the right side positive. And here I'm adding plus 1. So minus 1 also I have to do. Then minus 1, minus 9. So minus 9 taking to right side. Then that will be plus. So then similarly this is also minus 4. So then just you have to add this. Minus 4 is nothing but 100. So then simplify this one. So this is nothing but the value 25. This is so I'm taking, this is a minus, I think. So this is a plus. This is plus. So then this will get, I will get this value x minus 1 whole square by 25 plus y minus 2 whole square by 9 equal to 1. Then here a equal to 5 and the b equal to 3 from this one. Just you have to transform into such standard form of an ellipse. Then you will get a b values and hk values. So we want to find the length of the lattice rectum, that is nothing but 2b square by a. So then 2b square, 2 into b square values and 3 square. 3 square is nothing but 9. That is nothing but 18 by 5. So option 2 is the correct one for this question. Just first you have to transform into standard form. Next question. The ratio of the least and the greatest focal distances of a point on the ellipse 4x square plus 9y square equal 36. So then options are 5 plus or plus 5 plus root 3 is to 5 minus root 3. So 2 plus root 3 is to 2 minus root 3. So 2 plus 3 plus root 5 is to 3 minus root 5. And fourth option 3 plus root 5 is to 5 minus root 3. Just we have to find the ratio of least and greatest focal distances. Okay, so we have a formula that one we can find, from that one you can find that. So this is x square by a square plus y square by b square equal to 1. A is greater than b. So from this one, from the question, so we got the a square value is 9, b square value is 4. From this one we have to find the e value. So that is nothing but root of a square minus b square by a square. That then e value is 5 by root 3. So under root. So then ratio is nothing but, so 1 plus e is to 1 minus e. 1 plus e is to 1 minus e. So one value. So just you have to simplify. 1 plus 5 by root 3 is to 1 minus 5 root 3 5 by root 3, then you will get take LCM, then you will get this value. Okay, next, this is option 3 is the correct one. So then the distance of next question, the distance from foci of the point px1 comma y1 and the ellipse r. So distance from the foci, so that is nothing but a focal distance, we have to find that one. So then we have a formula. So this is, so 9x square plus 25y square equal to 225, that is nothing but x square by 25 plus y square by 9 equal to 1. So from that one we have to find that. So that is, so 5 plus or minus 4 by 5 x1, next 4 plus or minus 4 by 5 x1, 5 plus or minus 4 by 5 y1, 4 plus or minus 4 by 5 y1. So x1 y1 x1 y1. So we have the formulas. So that are, so this value, some, this is nothing but, here a is greater than b, so then e value is this one. So then focal distance is nothing but a plus or minus e of x1, e of x1, just you have to substitute. So e value, what is the a value? So here 5 value, so plus or minus e value, what is a value? 4 by 5 x1, 4 by 5 x1. So this is option 2 is the correct one for this question. So next, if the p, q are the segments of a focal chord of an ellipse x square by a square plus y square by b square equal to 1, then we have to find the pb square. We have to find the pb square. So then here pb square equal to q into 2ap minus b square, or qb square equal to p into, sorry, this is a p. So p equal to 2ap minus b square, pb square equal to q into 2ap plus b square, pb square equal to q into 2aq minus b square. So just we have to the, what is the focal chord is mentioned, the pq are the segments. Then so pb square value we have to find, then we have a formula. So that is nothing but, if psq are the focal chord of ellipse, then sp 1 by sp plus 1 by sq equal to 1 by sl. So then from that one, so this value, so then you will get so 1 by p plus 1 by q by equal to 2a by b square. So just to solve this one, so p plus q by pq equal to a by b square. So simplify this one. So then pb square plus qb square equal to 2apq, 2apq. So just we have to find the pb square value. We have to find the pb square, then you have to take the qb square into right side, then you will get minus qb square there. So pb square equal to 2apq minus qb square. So this is your pb square equal q into 2ap minus b square. This is the option 1 is the correct one for this question. Next, so position of a point, if let x1 comma y1 be a point and s equal to 0 is an ellipse, then p lies inside the ellipse if s11 values 0 less than 0, then if lies on the ellipse if s11 equal to 0. So we have this, just reminding this one. So if p lies outside of the circle, that values s11 value is greater than 0. Eccentric angle, so most important topic. So if p let p x comma y be a point on the ellipse with center c, and let n be the foot of the perpendicular of the foot of the perpendicular of p on the major axis, let np meets the auxiliary circle at p dash, then angle ncp dash is called the eccentric angle of p. Then point p dash is called the corresponding point of p, and its range is 0 to 2 pi. So what is saying that, so we have to draw a, so what is the auxiliary circle? So auxiliary circle, just to draw auxiliary circle, so no need. So this value, so then angle, so this is center c, I'm drawing like this, this is n, so this is p dash. Okay, so then angle, so this angle is saying that eccentric angles. Okay, next, if a circle cuts an ellipse in 4 distinct points, so a circle cuts an ellipse in 4 distinct points like this. So if like circle like this, then this is ellipse I'm taking, this is circle, so like this, the distinct points, then some of their eccentric angles, so angle at here and here and here, and the here value, so that value is nothing but multiple of pi radians, theta 1 plus theta 2 plus theta 3 plus theta 4 equal to 2n pi. Okay, next, So S are the foci of an ellipse. Then the normal at any point P uh, on the ellipse is the internal angular bisector of S dash PS, and tangent at P is external angular bisector of S dash P S. So here what is saying that S dash are the foci and of an ellipse, then the normal at in any point P. So of a ellipse, that is the internal bisector of that one. So now, so tangent is external bisector, angular bisectors. So for the same S dash P S. So next, at most four normals can be drawn. At most four normals can be drawn from a point to the ellipse, and the sum of the eccentric angles, of the feet of normals, to an ellipse through a point. A point is an odd multiple of pi radians. That is nothing but theta 1 plus theta 2 plus theta 3 plus theta 4 equal to 2n plus 1 of pi. So here at most four normals we can draw from the point of the ellipse, and the sum of eccentric angles of feet of the normals of an ellipse through a point is an odd multiple. So that is odd multiple. In the previous one, that is 2n pi is there only. Okay. Next, so parametric coordinates. So this is nothing but, if we know that in the previous discussion we have that x equal to h plus r minus h plus r cos theta, y equal to k plus r sin theta. We discussed in the circles. Same as usually here also, x equal to a cos theta, y equal to b sin theta are called the parametric equations of the ellipse s equals 0, and theta is a parameter. Theta is belongs to open interval 0 comma close interval 0 comma 2 pi of open interval. So then a point any point on the ellipse s equals 0 is this one, a cos theta, b sin theta, and it's called the point of theta. Then if center h comma k is there, then h plus a cos theta, k plus b sin theta. So that is the parametric condition. So equation of the chord is nothing but, this is the important question in IPA, that is nothing but equation of the chord joining points alpha and beta on the ellipse s equals 0 is x by a of cos of alpha plus beta by 2 plus y by b sin of alpha plus beta by 2 equal to cos of alpha minus beta by 2. We have already proved this one. Okay. So just you take the formulas only. So if alpha comma beta are the eccentric angles, so you are taking the eccentric angles of the extremities of a focal chord. So through s a comma 0 of an ellipse s equals 0, then so cos of alpha minus beta by 2 equal to e into cos of alpha plus beta by 2. This is also proved with the previous one. Next one formula is new. So that is nothing but, so tan alpha by 2 into tan beta by 2 equal to e minus 1 by e plus 1. E minus 1 by e plus 1. This is tan alpha by 2 into tan beta by 2 equal to e minus 1 by e plus 1. So the next, if the chord joining points alpha comma beta on the ellipse s equals 0 cuts the major axis. It's cut the major axis at a distance d. It's a distance d units from the center. Then tan of alpha by 2 equal to tan of alpha by 2 into tan of alpha by beta by 2 equal to d minus a by d plus a. What is saying that a chord joining points. Sorry. A chord joining points alpha and beta on the ellipse. The ellipse s equals 0 cuts the major axis at a distance d units from the center. Then tan of alpha by 2 into tan of beta by 2 is nothing but d minus a by d plus a. This is one formula. So next, if so we have a problem on that one. Sorry. If the chord joining points s p of alpha and q of beta on the ellipse x square by a square plus y square by b square equal 1 subtends a right angle at the vertex a comma 0 0. Then tan of alpha by 2 into tan of beta by 2 is, what is the value of tan of alpha by 2, tan of beta by 2? So then, so options are, so minus b square by a square, b square by a square, minus a square by b square, minus a, sorry, this is plus, one thing, one value is a plus I'm taking. So then here curved joining points p of alpha and q of beta on the ellipse. So given that at a right angle at a vertex, a, so then a comma 0, then tan of alpha by 2 into tan of beta by 2. Just we have to find the perpendicular slopes. So then this is a, p value is a cos alpha sin alpha, and q value is cos beta sin beta. So a value is this is a comma 0. So slope of ap into slope of aq, that is nothing but minus 1. Then b into, so just you have to find the slope of ap. What is the slope of ap? So here ap, so then this values a minus this value, so this value is a 0 minus sin b sin alpha. So sorry, here a cos alpha, b sin alpha, a cos beta, b sin beta. So just you have to note that. So then slope of ab into slope of aq, then just you have to find then slopes, then p sin alpha by a cos alpha minus a into b sin beta by a cos beta minus a equal to minus 1. So then here the values as per the submultiples, we can use this one, sin alpha 2 sin alpha by 2 into cos alpha by 2, and the b into b is there, b square, and this value also 2 sin beta by 2 into cos beta by 2, and this value taking a common from the denominator, so then a into a square from the both, then this is a cos alpha minus 1. So cos alpha minus 1 is nothing but 2 cos sin square alpha by 2 from the cos to theta formula. So then next 2 sin square beta by 2, same as usually. Then just simplify that one. So b square by a square here. So these two will get cancelled. So then this two will get cancelled. So then 1 sin alpha. So then 1 will be, so cos by sine, then we'll get cos by sine, then b square by a square into cot alpha by 2 into cot beta by 2 minus 1. So then just reverse this equation. So then you have to take this and reverse this equation. So then tan alpha by 2 into tan beta by 2 equal to minus b square by a square minus b square by a square. Then option 1 is the correct one for this one. Option 1 is the correct one. Just you have to do the product of slopes. Next, so an ellipse with the foci 1, 1, minus 1, 1 and passes through the origin, then its equations are, so equations, we have to find the equations of the foci of the ellipse. So solution for this one, foci given that s equal to 1, 1 and s dash is minus 1, 1 and passes through 0, 0, center is midpoint of foci, so nothing but 0, 1. So just you have to find the center ss dash. So distance, I mean midpoint of ss dash, then you will get the foci 0, 1, that is the center. Then so this is s dash equal to ae, distance between the foci is nothing but 2ae, that is root 4. So from this one root 4 you will get then 2, that a equal to 1. So we have the formula s plus s dash p equal to a, so that is sp value is 2 root 2 plus this is s dash b also root 2. So why? Because this was passing through this one, so then 2a. So then so a equal to root 2, then you will get a value as a root 2, then b square equal to, we have that a is greater than b, then that's why a square minus a square e square, then b square equal to 2 minus 1, b square value is 1. So then the required equation is nothing but this value. So that is x minus x1 whole square by a square plus y minus y1 whole square by b square, then x square x minus 0 whole square, that is nothing but x square by 2 plus y minus 1 whole square by 1. So just simplify that one, then you will get x square plus y 2y square minus 4y equal to 0. Okay, so option 2 is the correct one for this question. Next, the equation of the circle passing through the foci of the ellipse, x square by 16 plus y square by 9 equal to 1 and having center 0, 3. So here options are x square plus y square minus 6y minus 7 equals 0, x square plus y square minus 6y plus 5 equals 0, and x square plus y square minus 6y minus 5 equals 0. So this is x square plus y square minus 6y plus 7 equals 0. So here what is asking here, equation of the circle passing through the foci of this ellipse. So of this ellipse. So this is nothing but I'm taking an ellipse like this. So I have a focus here. So that another ellipse passing through this one. So then we have to find the equation of that equation of the circle. So that is a circle, sorry, that is not ellipse. So then we have to find this one, whatever it may be, like this. So then we have to, and having the center 0 comma 3, and having the center 0 comma 3. So which means, so there is no x value for this one, and the y value is that. So next, so then, so solution of that one. So circle passing through that foci, that is plus or minus a comma 0. So plus or minus root 7, sir. How can you find the foci, sir? A value, sir. So then just took this. So this is e value. E value is nothing but under root of a square minus b square. A square minus b square by a square. So just you have to take 16 minus 9. 16 minus 9 by 16 equal to root 7 by 4. Root 7 by 4. This is e value. So this is e value. So what is the a value from the this one? So a value is 4. Just a is there. A is nothing but root 7. Only root 7. So that's why we got that one. So okay, next. So this is plus or minus root 7 comma 0. So then radius is 4. Radius is, then the equation of the circle passing through the 0 comma 3 and the r equal to 4. So then just substitute x minus h whole square plus y minus k whole square equal to r square. Then and the equation, solve the equation, then you will get x square plus y square minus 6y minus 7 equal to 0. Okay, so this is the answer. Option 1. So option 1 is the correct one. So this is the previous MSET question. So the equation of the ellipse whose axes are axis of the coordinates, whose axis are axis of the coordinates, which passes through the minus 3 comma 1 and as eccentricity root 2 by 5 is. So options are given that 3x square plus 5y square minus 32 equal to 0, 3x square plus 5y square minus 15 equal to 0, 5x square plus 3y square minus 32 equal to 0, 3x square plus 6y square minus 32 equal to 0. So what is given that the equation of the ellipse whose axes are the axis of the coordinates and which passes through the point and eccentricity is 2 by root 5. So for that one we have to do solution. So required equation we are taking, that is x square by a square plus y square by b square equal to 1. Then so here passing through minus 3 comma 1 eccentricity is this one. So passing through minus 3 comma 1, just you have to do x comma 1, x comma y value substitute in this equation. Then you will get this value. So 9 by a square. So 3 square minus 3 square is nothing but 9. So 9 by a square plus 1 by b square equal to 1. Just you have to simplify this one. Then you will get 9b square plus a square. So 9b square plus a square equal to a square b square. So we have the formula eccentricity. So just we are using, that is eccentricity equal to we can write a square of 1 minus e square. A square of 1 minus e square, that is a b square value. So b square value we are using. So then b square value is nothing but, so b square value is a square of 1 minus e square. 1 minus e square. Just 1 minus e square. So then just write that one. So then you will get a square from these both ones. This will be gets cancelled. So 1 minus e square plus 9 of so here you can write this b square value also same like this. So then you will get this value 1 minus e square, a square minus 1. This is a square minus 9. So that is equal to 1. Just to simplify this one and taking common 1 minus e square, then you will get a square minus 9 equal to 1. So here the value is nothing but 3 by 5. This 1 minus e square value. So we have the value of e. We have the value of e. Then we'll get the 1 minus e square value is 3 by 5. A square minus 1. Then just to solve a square minus 9 equal to this value, taking this one. So then this will be the 5 by 3. A square equal to 32 by 3. A square equal to 32 by 3. Then b square equal to a square into 1 minus e square. Then b square value just simplify. Then you will get 32 by 5. 32 by 5. So then that 3x square by 32 plus 5y square by 32 equal to 1. Then the equation is 3x square plus 5y square minus 32 equal to 0. So where if a is greater than b. So in the question he mentioned this far. In the question options are like this. Okay. So now okay, sorry. So here see this. See this. So here from the using the eccentricity and the a square b square values, we got the a square b square values. So then we got an equation. If a is greater than b, I'm taking a is greater than b. Why? Here the value is nothing but b square equal to a square of 1 minus c square. If a is greater than b is the condition, then this is the correct answer. If he mentioned a is less than b, then this will be the correct answer. 5x square plus 3y square minus 48 equal to 0. So just to have to, we don't know what is a is greater than b or and a is less than b. Just to have to take both of that one. So as per the options, you have to take the answer. As per the options, you have to take the answers. Okay, so just do that. If a is greater than b, what will be happen? So if a is less than b, what will be happen? So this is the answer. So I'm taking here a is greater than b. You can take a is less than b, then you will get this answer. So as per same process, so then b square value may be changed. So that's the option 1 is the correct one for this one question. So the distance of a point on the ellipse, x square plus 3y square equals 6 from the center is 2 units. Then the eccentric angles of a point is nothing but the eccentric angles. We have to find that one. That is 11 by 4, 3 pi by 4, 13 pi by 4, 7 pi by 4. Just simple. So this is cos theta. Sorry, center 0, 0, and this value is p is root 6 cos theta, root 2 sin theta, and the cp is nothing but 2. So just we have the values. So distance between those two, you have to take that one, x2 minus x1 whole square. Then 6 cos square theta plus 2 sin square theta equal to 4. Then this from this one, so you can write. So this can be 4 cos square theta plus 2 cos square theta. Split that one. So then 2 sin square theta is there. So 2 cos square theta plus 2 sin square theta is nothing but 2. So identity formula. Then 4 cos square theta equal to 4 cos square theta equal to 2. So then this value take it to right side, then you will get 2 value. So then, and this will be gets cancelled. You will get cos square theta equal to 1 by 2. So then cos theta equal to 1 by root 2. So cos theta equal to 1 by root 2. So then it will be possible pi by 4, 3 pi by 4, 7 pi by 4. So from the options, 7 pi by 4 is the correct option. 7 pi by 4 is the correct option. Next. So if s dash are the foci of the ellipse x square by 25 plus y square by 16 equal to 1, if p is any point on it, the range of, so you have to take this assignment sp into s dash p is taking this assignment. So then you have to do this. So s and s dash are the foci and of the ellipse. So just you have to find the foci, and p is any point. Then sp into s dash p range, we have to find the sp s dash p range. Then you have to do that. Next question. If the chord through the points whose eccentric angles are theta comma phi, then the ellipse on the ellipse x square by a square plus y square by b square equal to 1 passes through the focus. Then tan theta, tan of tan theta by 2 into tan pi by 2 is. So just you have to find the values. So in the previous sum I was explained this type of sum. So just you have to do. Next, last question I think. So if theta 1, theta 2 are the eccentric angles of the extremities of a focal chord of an ellipse, then the eccentricity of the ellipse. Just we have to find the eccentricity of the ellipse. So just you have to use the formula theta 1, theta 2. That is nothing but a cos theta 1, comma b cos theta 1, a cos theta 2, b cos theta 2. So eccentric angles, then extremities of the focal chord. Then you have to find the eccentricity of the ellipse. Then use this. Do this. So thank you. Thank you, Manadal. Okay, this is the end for today. Tomorrow we discuss class 2 of the ellipse. I hope all you understand this one.